हाय एवरीवन, स्वागत है आपका बायजूस एग्जाम प्रेप गेट एंड ईएससी यूट्यूब चैनल पर। सिविल, एक्सी एंड मैकेनिकल, बेसिकली 3 branches we are dealing here on this channel. Today's session is dedicated to fluid mechanics for those students who are preparing for Barc examination. My name is Joshit Singh and I welcome you all in this session. Please let me know if my audio and my video is clear to all of you, and then we will move ahead and I'll show you the questions that I have for you. Unfortunately, today Chandrasekhar sir is not able to join this session, but soon he will be come live with some other amazing session. ठीक है, मेरी आवाज अच्छे से आ रही है तो एक बार कमेंट बॉक्स में बताओ मुझे, और फिर स्टार्ट करते हैं सेशन को। फटाफट से कैलकुलेटर वगैरह लेकर के रख लो, शेयर कर दो सेशन अपने दोस्तों के साथ और लाइक भी कर देना। अब आए हो तो लाइक तो कर ही दो, क्या ही होता है एक लाइक में। मेरा नाम जोशित सिंह है, आप सबको अगर पता है तो अच्छी बात, नहीं पता है तो जोशित सिंह नाम है मेरा। तजुर्बा 4 साल से ज्यादा का, एमटेक आईआईटी रुड़की, और आज जो मैं सब्जेक्ट ले रहा हूं आपके लिए उसी में मेरा एमटेक भी है। ग्राउंड जीरो जो सीरीज है वो लाइव हो चुकी है ऑलरेडी। सोम का एक टॉपिक डल भी चुका है, आशा करता हूं आपने देखा होगा। ब्रह्मास्त्र सीरीज, आज ब्रह्मास्त्र सीरीज का ही सेशन है आपके सामने। एक बार मैं आपको ग्राउंड जीरो का शेड्यूल दिखाता हूं, जिसमें आपके सामने आपको वीडियो मिलेगा स्ट्रेंथ ऑफ मटेरियल का सबसे पहले, एंड उसके बाद फ्लूइड मैकेनिक्स मैं और चंद्र सर लेके आने वाले हैं। इसमें आपको जो हम वीडियो देंगे दैट विल बी हाई क्वालिटी, हाई कंटेंट, और यू कैन से बेस्ट ऑफ द बेस्ट। ठीक है, मुझे लगता है अब हम तैयार हैं। एक बार कमेंट बॉक्स में मुझे बता दीजिए कौन कौन जुड़ चुका है मेरे साथ। फिर मैं स्टार्ट करता हूं पहले सवाल के साथ। ज्यादा वक्त नहीं लूंगा, मुझे फटाफट से एक बार बस कमेंट बॉक्स में लिख दो कि आवाज बहुत अच्छी है, और फिर मैं आगे बढ़ता हूं। जल्दी फटाफट से। हाँ जी दोस्तों, आवाज आ रही है भाई? जो भी देख रहा है बस बता दो, ऑडियो क्लियर है तो सीधे सवाल पे चलते हैं, फिर ज्यादा वक्त बिताते नहीं है। गुड वॉइस, थैंक यू सो मच। Let's begin now with the very first question of today's evening. So here's the first question. Let's see the question, what they are saying. The boundary layer thickness at the trailing edge when a flat plate of 10 centimeter wide and 55 centimeter long is placed longitudinally in a stream of fluid whose kinematic viscosity is 1 stoke flowing with a velocity of 8 meter per second is how much? Boundary layer thickness they are asking. We know boundary layer thickness, how we can find it out, but before that we need to know that what kind of boundary layer we are having, whether it is laminar or it is turbulent. For that we need to find out the local Reynolds number in this case, right? So Reynolds number, how to find it out? How to find it out? It is going to be how much? It is going to be the velocity into length by kinematic viscosity. Everything is given to us. Velocity is 8 meter per second. Length of the plate is given to us and it is 55 centimeter, so 0.55 divided by kinematic viscosity is given to us as 1 stoke. 1 stoke means 10 raised to the power minus 4. Now when you solve this, the Reynolds number value, एक बार आप मुझे comment box में बता भी सकते हैं, otherwise I'll tell you it is 4.4 into 10 raised to the power 4. So this is the Reynolds number value. अच्छा, whether it is greater than or less than the critical Reynolds number. What is critical Reynolds number? Critical Reynolds number is 5 into 10 raised to the power 5. Definitely it is less than that. So we have a laminar boundary layer. Good evening, Kiran. Now we know that for boundary layer, Blossius has given us the solution, that is delta by x is equals to 5 or 4.9, given different books. Okay, in different book it is given different, no problem. Let's put the value here. So delta is going to be 5 into x is nothing but it is 0.55. Put the value here as 0.55 divided by under root, आपके पास जो Reynolds number निकाला आपने, that is 4.4 10 raised to the power 4. Put the value 4.4 10 raised to the power 4. When you calculate this, how much is the value of delta you guys are getting? Can I know please in the comment box? Everybody quickly please, come on, this session is for you, not for me. मतलब मेरी प्रैक्टिस तो हो ही रही है, आपकी भी जरूरी है। ठीक है, जल्दी से बताएंगे। अपने दोस्तों के साथ सेशन को शेयर करते रहो यार। बाकी नए अगर आप हो तो सब्सक्राइब करके बता सकते हो कि भैया आप यहां पे जुड़ गए हैं। 1.3 सेंटीमीटर किरण ने जवाब दिया था सबसे पहले। वेरी गुड, ब्रिलियंट, सुपर, ऑल द वेरी बेस्ट फॉर द नेक्स्ट क्वेश्चन। नेक्स्ट क्वेश्चन सेज दैट the flow rate of water through the pipe in a fully developed flow through pipe of dia 160 mm and shear at wall is 78 Newton per meter square is how much? They are asking us the discharge. So do I have anything, and friction factor is also given to me. Do I have any relationship with which I can have a relation between friction factor, velocity, shear stress, or anything like that? That is a shear at wall. Remember this, because if you try to recall, there is a relationship that I have discussed with you in the classes also a lot of time, right? So it is your friction factor equals to 8 times of wall shear divided by rho v square, right? So from here we can find out the velocity. We have dia है, velocity है, discharge we can get. So let's find out the velocity from here, guys. So velocity is going to be how much? It is going to be 8 tau w by rho f under root. Kindly put the values here. See what you are getting. So 8 into 78. Density, what is it? This is water. So 1000. F 0.05. How much is the velocity? Has anyone found it yet? How much is the velocity, guys? Is it 3.532 meter per second? Super. एक बार आपके पास velocity आ गया. Now we are good to go to find out the discharge. Now discharge is nothing. It is area, cross-sectional area into velocity. Area is going to be how much? Pi by 4 d square. So pi by 4. Dia is how much? 160 mm. So 0.16 meter. Pi by 4 d square into velocity is 3.532. When you put the value, how much is the discharge? Who will tell me, Kiran? Tech IK. Everybody quickly answer. 0.071 meter cube per second. And what if they would have asked the same thing in liter? अगर बेटा लीटर में पूछ लेता तो क्या जवाब देते आप सभी लोग? कमेंट बॉक्स में लिख देंगे फटाफट। शेखर, वेरी गुड, बताइए। इफ दे वुड हैव आस्क्ड यू इन लीटर तो इसका जवाब आप क्या लिखते? क्या है आपका जवाब फॉर लीटर? ये तो मीटर क्यूब पर सेकेंड इन्होंने यहां पे लिखा था, तो इट वॉज वेरी एविडेंट दैट कि इसी में देना है। मान लो अगर देते, वेरी गुड, देन इट वुड बी 71 लीटर पर सेकेंड। 71 लीटर पर सेकेंड, वेरी गुड। अगला सवाल देखते हैं। फॉर अ लेमिनार फ्लो थ्रू अ सर्कुलर पाइप, द काइनेटिक एनर्जी पर सेकेंड ऑन एक्चुअल वेलोसिटी इज 90 जूल फॉर एक्चुअल वेलोसिटी। देन काइनेटिक एनर्जी पर सेकेंड बेस्ड ऑन द एवरेज वेलोसिटी विल बी इक्वल्स टू हाउ मच जूल? बताइए बेटा। काइनेटिक एनर्जी करेक्शन फैक्टर का एक्सप्रेशन याद होगा आपको। करेक्शन फैक्टर हम लोगों ने क्लास में भी समझा था, बड़ा आसान है इसको बताना। दैट इज काइनेटिक एनर्जी पर सेकेंड बेस्ड ऑन एक्चुअल वेलोसिटी डिवाइडेड बाय काइनेटिक एनर्जी पर सेकेंड बेस्ड ऑन एवरेज वेलोसिटी। सो काइनेटिक एनर्जी फैक्टर इज हाउ मच फॉर द लैमिनार फ्लो, गाइस? दैट इज गोइंग टू बी 2 equals to how much for actual velocity given? 90. And they're asking you this, right? Kinetic energy per second corresponding to average velocity. So it is going to be how much? So kinetic energy per second based on the average velocity corresponding to average velocity is equals to 90 by 2, and that is 45 joules. You guys are super. Anand, very good, very good, brilliant. Right answer is 45 joules. Next question for you guys. Super question for super student Shekhar, Kiran, very good. Keep answering. A viscous fluid was flowing in a laminar regime in a 6 centimeter dia circular pipe. If a petard tube at a radial distance 2 centimeter from the inner surface of the pipe indicate a velocity of 6 centimeter per second, then maximum velocity is how much? This is the case of a flow through pipe, and that too laminar. They have said na viscous fluid is flowing in a laminar regime. In the first line itself they have cleared. पहली लाइन में उन्होंने बता दिया है कि क्या माहौल है यहां पर. प्लीज आंसर. देखिए सर, मैक्सिमम वेलोसिटी पूछ रहा है. एक मैक्सिमम वेलोसिटी और एक नॉर्मल वेलोसिटी के बीच में एक रिलेशन है, बड़ा आसान सा रिलेशनशिप है, एंड दैट इज u बराबर u मैक्स ब्रैकेट 1 माइनस r square by r square. Small r square is the distance, radial distance from the center line, and capital R is the radius of the pipe, right? So now at given, now what is the value given? Radial distance 2 centimeter. Okay, at radial distance 2 centimeter from inner surface. बेटा 2 centimeter inner surface से बोला है. 2 centimeter from the inner surface they are saying, right? So what is the value of small r? ये ऐसा है कुछ. मान लो ये पाइप है, ये सेंटर लाइन है, तो ये यहां से बोल रहे हैं 2 सेंटीमीटर, राइट, एंड ये टोटल है कितना 3 सेंटीमीटर. हमको चाहिए ये, दैट इज स्मॉल आर. तो स्मॉल आर वुड बी हाउ मच? 3 minus 2, that is 1 centimeter. Superb. R is what we have got, capital R we have got. U, we know how much is the U value, that is 6 centimeter per second. Let's put the values and eventually find out the maximum velocity in centimeter per second only. Put the values everybody. So 6 is equals to U max. 1 minus small r value is 1 square by 3 square. Bracket close, and from here we'll be getting the answer as 6.75 centimeter per second. And very good, Anand, Kiran and Shekhar. और भी लोग जवाब देंगे तो अच्छा लगेगा. बहुत बढ़िया. अगला सवाल क्या कहता है देख लेते हैं. सवाल कह रहा है, in a laminar flow between two parallel plates with a separation distance of 4 mm, the center line velocity is 1.6 meter per second. The velocity at a distance of 1 mm from the boundary is how much? Please answer sir. बताइए. Velocity at distance 1 mm from boundary. They have told you that separation is 4 mm. Center velocity, center line velocity is given. Means maximum velocity is given to you. What else you need? सब आपके पास. बताइए. अगर किसी को if you don't remember the equation that I can help you with, so it was u is equals to minus 1 by 2 mu 1 by 2 mu del p by del x and then hy minus y square. H is the thickness between the parallel plates and y is the distance from the सरफेस. ठीक है, कोई भी सरफेस आप ले लो, सॉलिड बाउंड्री ले लो, दैट इज द होल थिंग. ठीक है सर, तो इसको आप निकाल लो फटाफट से, जवाब मजा आ जाएगा. देयर इज अ वेरी इजी वे टू डू इट. यू कैन डू इट लाइक दिस. वेलोसिटी एट व्हाटएवर डिस्टेंस यू वांट डिवाइडेड बाय सेंटर लाइन वेलोसिटी. इट शुड बी इक्वल्स टू हाउ मच? माइनस 1 बाय 2 म्यू, करेक्ट, डेल पी बाय डेल एक्स. Where they are asking 1 mm from the boundary, right? H we already know. H is how much? 4. So 4 into 1 minus 1 square divided by minus 1 by 2 mu. Center line. So we know it is how much? Del p by del x. This would be 4 only, but here this time it will be 2 minus 2 square. But remember guys, everything we have considered in mm. अभी mm में लियो, then we need to convert this also in terms of meter, because meter per second is what we are looking for, right? या तो कर लो या anyways it will be cancelled out, तो एक ही बात पड़ेगी. This velocity is given to us, So it is U by how much? 1.6 equals to, everything will be cancelled out, cancel out, cancel out. This will be 4 minus 1, 3, and this will be 8 minus 4. That's 4 only. So from here, the value of U is how much? Now let's see who is going to answer this quickly, everybody. Directly you can answer now without even solving it. Very good, superb, and that is 1.2 meter per second. Very well, very well, very well. Moving on to the next question now. The question is very beautiful and very simple and very important as well. An open cylinder of 20 centimeter dia and 160 centimeter height contains water up to height of 100 centimeter. Okay, I'll make the diagram for you. Okay, or you do one thing, give it a shot. You guys do it quickly. All right, open cylinder है 20 centimeter is dia. Okay, 20 centimeter is the dia and 160 is the height. Water up to 100 centimeter. The speed at which rotate so that axial depth becomes 30 centimeter. So this becomes 30 centimeter. Okay, we need to find out this very easy thing. See, we know the relationship that Z is equals to omega square R square by 2G. Omega square R square by 2G. Now the thing is, omega we want, right? Omega means omega once we can get the value of RPM also. Radius we have, that is 10 centimeter. Z, how much would be the value of Z, everyone? Z कितना हो जाएगा? बताइए. देखिए, how much distance do we have here? 100 centimeter, correct? 100 centimeter इधर था, and how much is left over here? 60, right? So if it wants to leave only 30 centimeter here, means 70 it must have come down, and 70 also it must have gone up, right? So water will be till here only, top tak. Okay, so now the value would be very simple to find. 160 minus 30 by 100, because I want it in meter. Omega square, R is how much? R is 0.1 square by 2 into 9.81. From here the value of omega is how much? कोई देगा मुझे को एक बार omega का value? 50.50 radian per second. Very well. Very well. Once omega we have got, we know omega is equals to 2 pi n by 60. Put the values, and the value of n would be around 482.24 RPM. So C is the right answer. यहाँ पे अब गलत हो गया एक क्वेश्चन का आंसर, कोई बात नहीं. अगला सवाल. Okay, given that atmospheric pressure head is 9 meter, vapor pressure head is 1 meter, failure head is 40 meter, cavitation coefficient is 0.15, Thomas cavitation factor also you can say. The height at which turbine can set above the tail race level is what? Please sir answer करेंगे. Atmospheric pressure head is given, HATM is given. Vapor pressure head given. Okay. Failure head is also given. Thoma cavitation is given. How much is this value? That's what they're asking. देखो, this is what? This is your atmospheric pressure head minus vapor pressure minus this divided by failure head. It is given to us as 0.15, ATM is 9 minus 1 minus the value I need by 40. When you solve this, HS is how much? Can you quickly do the calculation and tell me quickly, everybody? टू मीटर है क्या? It must be 2 meter, which is option D. Set है everybody? क्या हो गया भाई? आलस आलस नहीं आने देंगे, एग्जाम थोड़ा ही दूर है, राइट? नेक्स्ट क्वेश्चन करते हैं. नेक्स्ट क्वेश्चन बोलता है a laminar fluid flow of viscosity 0.8 Newton second per meter square and specific gravity 1.3, okay, if flowing through a circular pipe of dia this much, pressure gradient is given, average velocity is how much? Please answer. See, we can use one relationship because this is flow through pipe, right? We know that average velocity is half of maximum velocity, correct? And what is maximum velocity? Half of this. I have already wrote, I think, somewhere, right? Before, in this session only, before this particular concept, 1 by 4 mu del B by del X into R square. Come on, put the values. 1 by 2, 1 by 4.8. This is given as 7848. And R is how much? 150, 75.75 square. So when you solve this, the average velocity comes out to be 6.9 meter per second, which is option A. Very good, Kiran. वेरी गुड, कम बैक, बहुत अच्छा है. अगला सवाल आपकी स्क्रीन पर है, प्लीज जवाब देंगे. ऑयल जिसका काइनेमैटिक विस्कोसिटी है 1.0 इंटू 10⁻⁻5 मीटर स्क्वायर पर सेकेंड, फ्लो थ्रू अ पाइप ऑफ 0.3 मीटर डायमीटर विद अ वेलोसिटी ऑफ 8 मीटर पर सेकेंड. Water kinematic viscosity this much is flowing through a model pipe of dia this. For satisfying the dynamic similarity, velocity of water is how much? Beta, bas tell me one thing. Which dimensionless number do you think we have to use here? Please बताइए. Yes, Reynolds. So Reynolds number for model should be equals to Reynolds number of prototype, correct? So it is going to be how much? Rho m Vm dm by mu m. Rho p Vp dp by mu p. Since kinematic viscosity is given, so I can write it as rho, instead of rho we can use, leave it, we can use Vm dm by nu m equals to Vp dp by nu p. Now put the values. V is given to you as 8. So 8 into this is given as 0.3. Kinematic viscosity 1 into 10⁻⁻5. And here we need velocity. dp is given to as 0.02 and kinematic viscosity 0.89 into 10⁻⁻6. From here the velocity that we should get is 10.68. I have done the calculation already. Very good, yaar. Anand, superb, yaar, superb. Next question, please try to answer this. Very easy question it is. Please answer, everyone. In a sample of water, a pressure increase of 15 into 10⁶ Pascal caused a 2% reduction in its volume. What is the velocity of pressure wave in this water? बताइए सर, velocity in the pressure wave. Basically this is what I need. C is equals to K by rho. Now for that we want K. अभी K कैसे आएगा? That you can see. You have pressure increase, you have percentage reduction in the volume. So we know that bulk modulus is equals to increase in pressure by volumetric strain. right? So we can use it. It is going to be how much? Minus 15 into 10 raised to the power 6 divided by how much is the volumetric strain? It is 2 by 100. And from here we get the value as 750 into 10 raised to the power 6 Newton per meter square. Okay, sir. This is one thing. Now put the values. So C is equals to 750 by how much is the density? This is water, I guess. So 1000 we know. Also 10 raised to the power 6 we had to put under root. So how much is the velocity you are getting? Can anyone tell me in the comment box? This should be 866 meter per second. Correct? Very good, yaar, Kiran. Superb. Next question. I think this is the last question, but best question, I would say, from today's class. A square tank 1 by 1 of depth 1 meter has a square hole of size 1 centimeter by 1 centimeter at the middle of its bottom with a valve. How much time in minute will it take for a tank to go from full to empty once the valve is opened? Coefficient of discharge is 0.68. Try to answer, please. This is 1. This is 1, right? And it is opened from here. Try to answer this. You know that area of tank is how much? Area of tank is 1 by 1, that is 1 meter square, and area of the hole is 1 into 1, that is 1 centimeter square, or 10 raised to the power minus 4 meter square. Now discharge, we know that discharge can be given as CD A under root 2GH. Correct? Now the point is H is changing with respect to time, right? H जो है वो change हो रहा है with respect to time. Correct? We should use 12 by C. Where previous in the previous case, here you are saying gradual closure, or you are asking general doubt here, because things are entirely different, right? So guys, because the H value is changing, keep on changing, so let's see how we can deal with this. What we can do is we can take a strip over here, right? Let's say the thickness of the strip is DH. Now we know that change in volume. Now this is beautiful. Please see this. Change in volume. I'll disappear myself so that you can see what I'm writing. Change in volume can be given as discharge into dt time. Correct? That's the change in volume. And this happened equal to what? In dt time, this much change in head came. So you are saying that it is A into DH. Correct or not? If you agree with this, please send me a heart sign or write CC in the comment box. Everybody. Right. So from here we can say that dt is equals to minus ADH divided by, instead of discharge, you can put the value of this thing, CDA under root 2GH. Now we are good to go. If we integrate this, it is going to be, take constants outside. Area is constant, CD constant, A constant, 2G constant. Rest, we have to see the limit 0 to 1, DH by under root H. Now all you need to do is put the values and solve it. When you solve it, guys, what you are going to get is, let me tell you, 6633.41 seconds. Right? And it is nothing but it is 110.56 minutes. Who gave the answer first? Very good. Very good. Anand has given it. Very good. Right. Yes, Kiran. That's what we are doing. Right, sir. So this is the solution for this. Right. Okay. I have one question for you as a homework. Let's see how many of you will answer this in the comment box. After the class, you can give the answer in the comment box, right? And that's it. Super simple session, but useful session. If you want the PDF of the class, you will get it in Civil by Ninja Sir Telegram group. If you are watching me for the first time here, you can subscribe the channel, hit the like button and share this video with your friends. I'll meet you in the next class now. Till then, please take care of yourself and take care of your family as well. Have a nice day. Good night and bye-bye. Thank you so much. Thank you so much for joining.